Hi, I'm Matt Shula, and I'll be giving you a quick demonstration of the Galaxy Data Mines tool. If you want to learn more about the tool, you can visit this repository at my username /Galaxy Data Mines. Here you can see kind of what the project's about, sort of the reasons behind creating it. But I'll try to give a brief description right now before we jump into the tool. So essentially, the Galaxy Data Mines tool is a command line application that compares object classifications between NED and SIMBAD. And NED is the NASA Extragalactic Database, and SIMBAD is the set of identifications, measurements, and bibliography for astronomical data. Quite a long acronym there, but essentially these are two pretty widely used databases by astronomers. And some of the issues that come into play are when these two data sets give classifications to common objects because they use two different classification schemes. So if you go into the documents folder here and the final report, actually outline in this section here NED's linear scheme versus SIMBAD's hierarchical one. And this is just a subsection of each, but essentially the tool will map an object's classification from NED to SIMBAD and will determine the match type there. So if you're interested, you can check out more of those details here, but I'm just going to jump into the tool because that might be the best way to learn about it. So you can run the tool just by typing in the Galaxy Data Mines GD Mines command, and when you do that, you get the usage of the command, little description, the options associated with the command or the application, and the commands itself. So let's try for demonstration purposes. Let's do the Galaxy Data Mines command, and we'll run, let's say, show table, and we'll do the by name command, and we'll search for the M83 galaxy. So doing that, you can see that a browser window opened up, and it's got a big table here with 200 entries. And on the right-hand side, you can see that there were these match types computed. So this is what I was talking about earlier. So you've got exact, candidate, of type, shared category, generalization, and no match types. And those were computed for each entry, each object that was found to be a match between the two systems. So the matches were first determined by the location given by these two columns. On the left-hand side, this is the NED data. On the right-hand side, this is SIMBAD. And you can see for NED, for example, let's take a look at the exact matches that are true. For NED, this particular object was classified as an X-ray source, and for SIMBAD, it was classified as X. So that's just a minor syntactic difference, but they really mean the same thing. So what happens is the NED classification is mapped to the actual analog to SIMBAD, and that's actually what gets compared, and then through that comparison, if they're equal, then they're an exact match. So that's kind of the logic behind the exact match. Each one of these has their own logic associated with them. As you can imagine, shared category will check if the two objects are in the same category, and it traverses a tree to do that, and I'll show you that in a second. Yeah, so this is just a general overview of the results. And you can export this table if you'd like. Let's try another command. This time, let's do the same command actually, and let's do object radius. So here you can actually specify what you want the radius around your search to be. Let's do 4 arc minutes here. The default is 1 arc minute, so this should expand the scope of the search quite a bit and return quite a few more results. So this time we open the table up, and let's display all results. And as you can see, we've got quite a few more results here. Looks like almost 2,000. Before we had 200, so a 10x increase in the amount of comparisons that were done. But again, you've got the same comparison logic sort of running for each of these objects. So let's go back here, and you can see on this screen what pops up is you can actually see a statistical summary of the match results as well. So here under query statistics, you can see that the object queried was M83. You get a high level overview. It looks like we got 6,000 objects retrieved there. Almost 2,000 objects were overlapping between NED and SIMBAD. From NED, we got almost 4,000 objects. From SIMBAD, roughly 2,500. And you can see the percent of NED match, the percent of SIMBAD. And like I was talking about earlier, the comparison results here, match types, you can see the strong matches, the weak matches, the combined matches, which are made up of these constituent elements. So the exact candidate of type are strong here, the same category, the generalization, are weak matches, just to sort of give you a better sense of how strong were these matches between the databases for this particular location. Looks like this search was mainly strong matches at almost 90%. And then you can also see here the number of objects that were actually compared in the results, and it'll calculate the total match rate, which is the combination of the strong matches plus the weak matches. So yeah, that's a little demo of that. One other thing you can do, which is pretty useful, is so you can see there when I queried that, it took a little while to come up with the results. It gets even longer if you increase the object radius even more. So here at 6 arc minutes, it might take a little longer to download things. So one thing that's kind of helpful, and also just for a level of detail, is to type in log info. And at this point, it'll actually show you what's going on behind the scenes for each comparison that's done. So here it's just going to scan through, do all the same comparisons it did before. It's going to launch the table, show you the results. You can do the same stuff you were doing earlier, but in addition, you can see what's going on. You can see this was an exact match computed. You know, it found the analog for NED. It matched it to SIMBAD. Here's a candidate match. It saw that, candidate match. It saw that there was some uncertainty associated with the object. With SIMBAD, it had a question mark in it, but it was able to resolve the name to CL star in NED, and that would be a candidate match. And as you can see down here, candidate match is still a strong type of match. And then another more sophisticated match would be a shared category match. So found that this HII object and SR question mark are in the same category here. So HII here, and then we're looking for SR question mark, which is right here. So these are all within the same category. So that's how that was computed. So you can kind of see like how things were done a little bit better if you have a question about why an object got the comparison it did. And again, you can look at the documentation I listed earlier. So one other thing I have to show you is this feature here, which is a two-dimensional representation of the results colored by match type. So if I do show plot here, and I'll change the radius to 3 arc minutes. So we'll run that same command again. No such option dash s. Didn't do a double dash there. So there you go. So now it seems to be working. So SIMBAD's currently being queried. So again, it takes a little while, but at least you know what's going on when it's being queried, when SIMBAD is actually where we're downloading the data. So NED, and then we get our comparison results again, launch the table, but this time we also have, in addition to this table here, we also get this figure. So this is the M83 results for the comparisons done in that particular region between NED and SIMBAD. So here you can actually zoom in and see how those objects compared, get a different level of detail there. Or when you zoom out, you can kind of get a high-level overview of how the general picture looks. So here we've got some blue at the top, some blue at the bottom. Which kind of, if you look at the legend, that corresponds to candidate matches. So NED sort of thought, I think this, SIMBAD sort of thought, I think this might be a certain type of object, whereas NED was like, no, I know I'm saying it's that object. So a little bit of uncertainty at the top and bottom, but in the middle, you've got exact matches. So it looks like they agreed kind of heavily in the middle. And you can see a little bit of structure in this galaxy. So we can even get even more detail if we increase the radius again. So let's do 6 arc minutes, and we don't really want to see the table anymore, not right now anyway. And we'll try that search. So we'll query the 2 databases again. And again, you can see sort of the you're starting to get a large amount of objects being returned here. You can't even see all of them behind the other ones anymore. So the more you zoom in, you can see that level of detail is just a very large amount of comparisons that were done. But still the same pattern and trend emerges. So yeah, you can use this to query any location you'd like. You can query not only by name but by location, and you can also run this program via a script, which I did, and I ran it on around 100,000 objects that were compared, and from the Messier data set. And if you're interested, you can check out the repository and check out the final report in the documents folder to see how those results emerge. But there were some trends that were found, and yeah, so thank you very much for checking out the video. I hope you enjoyed it, and yeah, thank you.